Welcome everyone to another episode of Clearly Conveying. Joining me today is Mr. Tim Wolf, VP of Engineering for PPI. Today we'd like to discuss a very important topic regarding flame retardant pulley lagging. So Tim, there's a lot of slang, if you will, used out in the industry with regards to flame retardant lagging. You hear MSHA lagging, you hear abbreviations like SOF. So let's just begin with maybe a discussion about what is MSHA approved lagging and what is SOF or SOF lagging.
Sure.
If someone asked you to define it, how would you do that?
So probably the three things that you really get into is fire resistance and static conductivity. And then the three kind of acronyms in that are MSHA, which is mine safety in the United States, and that has to do with flame retardants specifically. And then typically in more of a grain type application, you'll get into the acronym SOF, or sometimes they reverse it into FOS, but SOF, and so there the S is for static conductive, O is oil resistance, another piece in that specific area, and then F is for flame retardants. And then outside the United States, you'll often hear the word FRAS, F-R-A-S, and that also is for flame resistance and static conductive, and then the R and the A are for some other things there. So those are the common acronyms and what you're talking about.
Okay, perfect, and that's a good start. So with regards to MSHA and OSHA, I understand that OSHA actually has a test. So if you're going to meet OSHA regulations, it has to meet a certain test. And I think one of the criteria of that test is like 300 mega ohms of resistivity. So it has to be that or below. But MSHA really doesn't define a static resistivity. I think correct me if I'm wrong, they just ask that.
They make a reference to it.
Yeah, they make a reference to it that your product or your rubber lagging, for us, for example, just has to be enough to prevent a spark.
Correct.
Is that correct?
Yes.
So is it safe to say that MSHA, does reference static conductivity?
It mentions it. And then with MSHA specifically, there is no reference to pulley lagging or truthfully idler rolls and things like that too. They're specifically stated for belting and some of the other really large volumes of consumable materials that would get into typically an underground mine. But a lot of the users and engineers that spec things into those industries will apply what you take to the belt, and they'll apply it to pulley lagging and things like that. So producers of those products, like PPI making our lagging, we will send it into MSHA. They will do their actual test in their labs, and we will get a stamp that says that our lagging is MSHA rated and been tested.
Okay, fantastic. And there's different compounds that can meet that MSHA requirement, right? Like for us here at PPI, we have a 60 durometer neoprene lagging that meets those MSHA requirements, but there's different compounds that can be used that can meet that. And with regards, just a little more specifically about the MSHA, when we talk about flame resistance or flame retardant, there's some different plays on some of the language, but can you just clearly define what it means? Like when we say we have a MSHA approved lagging that is flame retardant, in kind of layman's terms,
Yes.
What does that mean?
Yeah, and the easiest is to kind of describe the test. So with the MSHA test, it's a certain volume of rubber in a certain shape, and you apply a certain amount of flame, heat to it that has a specified amount of BTUs, and you hold that flame to it for a certain amount of time and get it to starting to burn, and then you pull that flame source away, and that lagging material or belting material or what have you has to self-extinguish in a certain amount of time. And when it does all of those things, it will be deemed passing and get an MSHA stamp.
So that's the most important thing.
It's
like once the source is removed, the source of the heat or the flame or the fire, whatever, it will self-extinguish and not continue to burn.
Yes.
Okay, excellent. So moving on now, let's just talk about above ground applications. So what is one of the above ground applications where like an SOF or a FOS type of lagging would be required?
Yes, the other most hazardous application is grain handling. Grain dust also, when it becomes airborne, it's very easy to ignite into a flame, and that flame front can move very quickly and actually represent as an explosion. So indoor enclosed grain is where you really get into the SOF, and that's where they're very important on the static conductive part. They put a lot of emphasis into that, but they also want that flame retardance, self-extinguishing feature also. The old part of it really isn't from a hazard point of view, but grains have oils in them, vegetable oils, and that can be hard on a lot of compounds and cause them to deteriorate prematurely. So they also want that oil resistant feature in it also.
So static conductive, oil resistant, flame retardant, all three, with regards to lagging going into a grain industry.
Yes.
Okay, fantastic. Any particulars, like when it comes to oil resistance, okay, help us better understand why that is important. Like if oils can impregnate your rubber, what's the hazard in that?
Oils can become, some of them are naturally a solvent. And a solvent takes something and makes it softer and potentially a liquid, and it can also make them swell. So in the context of polylagging, if it is hit with enough oil and it's not resistant to it, your lagging will swell up, it will become softer, and then its properties really won't work well for driving your conveyor. It might become gummy, it might wear off a lot quicker, and that's the type of damage or performance issues that you would see.
Mm-hmm. Okay, fantastic. So to wrap things up, I think it's important to just know our application best, right? So if you're a distributor and you're selling products into mining operations, it'd be important to understand, is this going above ground or below ground? And specifically, if you're selling products into the grain industry, because of the OSHA regulations regarding static conductivity, and they actually have an actual test that you have to meet, it's important to know your customer and know what product is best to specify for use in those applications.
Right, and grain especially, because in the OSHA regulations, it specifically states, grain, you need to worry about these things. So there, it's explicitly stated. On the underground mining with MSHA, technically polylagging isn't stated, but a lot of mine operators take a conservative tack. They want to really protect their people and their operations and whatnot, and so they'll apply the requirements for belting and other things that are specifically stated to the polylagging and some of their other polymer sources in their mining equipment.
Okay. And with regards to PPI lagging products that are available, we do have information available on our website, and then technical notes that's available upon request if anyone has any more technical questions about SOF or MSHA approved like neoprene lagging for us.
Yeah, and if you want us to come, we've got a great group of product engineers and a great group of field engineers that can take those things to you if you want us to help you in person.
Okay. Well, fantastic, Tim. Thank you so much for sharing that wonderful information. Thanks everyone for joining us, and we'll see you next time.
To expand that just a little bit more, anything that's power transferring. So you could have a head discharge pulley that has a backstop on it or a brake or something like that. That's not as common, but on very large mining conveyors, that's a